Alright, in this video we're going to do some worked examples on how to write the subshell configuration, but for elements beyond 20. So these are the more complex questions that involve backfilling. We'll start with calcium, which is element number 20. This is actually the first one before backfilling begins, so it's a good one to start on. So calcium is number 20. Its normal electron configuration is 2, 8, 8, 2. So that means its subshell configuration will have 2 in the first shell, 8 in the second shell. So the 2s is full, the 2p is full, it has 6. The third shell is the same, its s is full, then its p is full. Then we get to the fourth shell, so it's s. Those 2 electrons are in that 4s, and then we're finished. So now we're up to scandium, which is number 21. That's the first transition metal, so we're always thinking, okay, backfilling is happening. And that's because, remember, all these transition metals are called the D block elements. So we're filling up the D subshell. So scandium will have exactly the same electron configuration, but 1 extra electron compared to calcium. So it has 2, then 8, then we're backfilling into the third, and 2 in the fourth shell. And so the subshell configuration looks pretty similar to calcium. Everything's the same for the first 20. But then once we finish the 4s subshell, well, the 3d is the next subshell to fill according to our diagram. So then we're going to have the 3d having that 1 extra electron. All right, titanium is the next one. It's only 1 beyond scandium, so we're going to have an extra 1 in the 3d subshell. So the second shell's full, the 3s and the 3p are full, the 4s is full, and now we're still continuing to backfill, and now we have 2 in that 3d subshell. And so that means titanium has 2 in the first, 8 in the second. Add together all of our 3, we now have 10 in the third, and still 2 in the fourth. So that's its normal configuration. All right, let's skip ahead to zinc, number 30. Zinc is at the end of the D block, so it's finished filling up its 3D subshell, which means it has 2, then 8, and now its third shell is completely full. It has 18, and it still has those 2 in the fourth. So the subshell configuration will be similar to titanium, but that 3D subshell is going to be full with all 10 electrons that it can hold. First shell, 2p, 2s and 2p, then the 3s and the 3p, then the 4s is full, and then our 3d is full as well. It has all 10 electrons, and that gets us to 30 electrons, which zinc has. Okay, jumping down lastly to tin, element number 50. So we now are down in the 5th period, so we've got 5 electron shells. So let's write the electron configuration firstly. It's going to have 2 in the first, then 8. That third shell will be full. Its fourth shell, so we had 2 of the fourth shell filling up here. Then we had 5 more filling up here. And then all of these transition metals were filling up the 4D. So the fourth shell also has 18. Then the 5th shell has 2 here, plus another 2 here. So you can see once you get down to these later elements, it's harder to work out the normal electron configuration. It's a lot easier to work it out using the subshells. Otherwise, you have to do it manually on the run like I'm trying to do. So our electron configuration should be 2, 8, 18, 18, 4. And adding those together, we get 10, 28, 38, 46, 50 electrons. So let's write the subshell configuration. 1s is full, then the 2s and the 2p, then the 3s and the 3p, then the 4s, then we come back and backfill the 3d, which has 10, so our third shell is now finished. Then we continue the fourth shell, so we're continuing the 4p over here. 4p, and p can hold 6. And you can see we keep working along the periodic table to work out where we're filling. So now we're down here filling the 5s because we're in the s block. 5s2. Now we're here filling the 4d. And the 4d is full as well with 10. Then we get to the p block here, and we only have to fill 2 electrons in the p block. And so we're finishing the 5p, finishing with the 5p with our 2 electrons there. And adding together all these numbers should get us to our atomic number of 50 for 10. All right, so those are much more complicated than you'll get at year 10 level, but it's good to see how you write those later elements.